Prompt caching lets you mark a portion of your prompt, typically a long system prompt, a large document, or few-shot examples, as cacheable. On subsequent requests that reuse the same cached content, you're charged a significantly reduced rate for those tokens, and time to first token improves because Claude doesn't have to reprocess that content from scratch. You mark a cache breakpoint at the end of the content you want cached. Caches have a time to live, reused within the window. You get the discount, let it expire, and the next request pays full price and reestablishes the cache. Order matters. Structure prompts so stable. Reusable content comes first, and variable, per-request content comes last. Best fit. High-volume applications reusing the same large context repeatedly. Modern Claude models support very large context windows, which changes some traditional trade-offs, but supporting it and using it for everything are different claims. Dump the whole document when it fits and the task benefits from holistic understanding, summarizing a whole report, reviewing an entire contract. Retrieve selectively when the corpus is much bigger than one request needs. If you have 10,000 documents and a question only needs 3, retrieval is both cheaper and often more accurate than stuffing everything in. And position matters somewhat. Extremely long contexts can show mild recency effects. So when precision on a specific fact matters, well-structured prompts with clear section breaks help Claude locate the right information. Retrieval Augmented Generation, RAG, searching a knowledge base for relevant chunks and inserting only those, and simply relying on a large context window are two different strategies for the same underlying problem, getting the right information in front of the model. At the developer level, know the basic trade-off. Long context is simpler engineering, no separate retrieval pipeline. Better when the whole corpus is genuinely relevant or small enough to fit comfortably. RAG has more engineering overhead, embeddings, a vector store, a retrieval step, but scales to corpora far larger than any context window and can be cheaper per request. Both are legitimate tools, not one replacing the other. Before sending a request, you can count tokens for a given piece of text via a dedicated counting utility in the SDK. To estimate cost before making a call, check whether a document plus history will fit your budget before hitting a hard limit, and log per request usage for cost attribution. Don't estimate tokens by dividing character count by 4 and calling it done in cost-sensitive production code. Use the actual counting utility, since token boundaries vary by content. Code and non-English text tokenize less predictably than plain English prose. Since the API is stateless and every turn resends the full history, long-running conversations need an explicit strategy once they get large. Summarize and compact older turns into a condensed message once a length threshold passes, preserving the gist while dropping token load. Truncate the oldest turns entirely once they're no longer relevant. Riskier, since you lose information, not just detail. Or externalize state. Instead of relying on conversation history to remember facts, store them in your own application state and inject only what's currently relevant into each new request. Putting this chapter's techniques together, a cost-conscious production system typically puts stable content first and caches it, retrieves rather than dumps for large corpora, counts tokens before sending rather than guessing, and compacts or externalizes state rather than letting conversation history grow without bound. Take the running triage assistant and add a long, static system prompt, a realistic company policy document a few hundred words long, with a cache breakpoint after it. Make the same request twice in a row and compare the reported cache read versus cache write token usage in the response. To recap, prompt caching discounts reused stable content when structured with stable first, variable last ordering, and a cache breakpoint. Caches expire after a TTL. Long context windows let you include whole documents for holistic tasks, but retrieval is often cheaper and more accurate for large corpora where only a subset is relevant. RAG and long context are complementary strategies, chosen based on corpus size and per-request relevance. Use real token counting utilities rather than character count heuristics, and manage growing conversations via summarization, truncation, or externalizing state rather than letting history grow unbounded.